This is lesson 3.1, example 2. We are talking about two teams that went to soccer camp together. The teams were split into equally sized groups for their cabins, but the two teams didn't want to intermingle in the cabins. They wanted to stick with their own team. They needed to be in the largest possible groups to minimize the number of cabins being used. So how many soccer players were in each cabin? Team 1 had 36 players and Team 2 had 30. To do this, we're going to need to find our greatest common factor. We need to have equal groups and the greatest number of people in each group. That means greatest common factor. Now, we're not going to use the list the factors method this time. This time we're going to use the prime factorization method. Every number can be reduced to a number of prime factors. Every number is a product of prime numbers. So, to find out what those prime numbers are, we make a prime factorization, which looks a little bit like a tree. If you need to remember it as a prime factorization tree, that's fine. We're going to do it together now. 36, we'll start there. 36. We started out by saying, what two factors of 36 do we want to start with? What two numbers multiply together to make 36? And I'm going to start with 9 times 4. 9 times 4 equals 36. Neither of these are prime numbers, so I have to keep going. 9 is 3 times 3. 4 is 2 times 2. Therefore, 36 equals 3 times 3 times 2 times 2. This is the prime factorization of 36. Now let's do 30. 30 is a little bit different. What multiplies to get 30? Let's do 6 times 5. 6 is not a prime number. Therefore, we need to break it down. 6 is 2 times 3. 5 is a prime number. Only 1 and 5 go into 5. So 5 just kind of drops down. I don't ever put 1s in my prime factorizations because they're kind of pointless. Times 1 would be the same. I could put as many times 1 on here as I want to. It doesn't matter. 30, and I'm going to have to scoot this up a little bit. 30, there we go, equals 2 times 3 times 5. Now, I have my prime factorizations. How do I get my greatest common factor? Well, I find what prime factors these two numbers have in common. What prime factors do they have in common? Well, they both have a 2, and they both have a 3. Notice I'm not circling both 3's and both 2's. If they both had two 2's, if they both had two 2's, then I would circle both 2's. But as 30 only has one 3 and one 2, I'm only going to circle 1 3 and 1 2 over here. And yes, I know I'm not drawing squares, not circles. Whatever. Then I take these prime factors that they have in common and I multiply them. 3 times 2 equals 6. And that is our greatest common factor. Our greatest common factor is 6. So how many kids were going to be in each cabin group? 6.